Hey everybody, this is Larry. This is day 17 probably of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Today I ran a mile a little bit early on. It still hurts a lot, honestly, but just trying to, excuse me, try to get anything going, try to see what's up. And yeah, and we'll see how things go. No big deals, but yeah, let's take a look at today's farm. Man, my phone is having some issues right now. But yeah, today we have 1079 letter tile possibilities. You have n tiles where each tile has one letter tile survive printed on it. Okay. Return the number possible of non-empty sequence of letters that you can make using the letter printed on these tiles. Okay. I mean, and there are only 7 letters, so I guess, like, you could probably do something like 7 factorial, right? What is 7 factorial? 7 factorial is not that big, I don't think. It's like 5,000. So if you do 5,000, you put everything in a set, you'll be, you know. Oh, actually, I'm wrong because it's not just the ordering, but either way, yes. Even if you want to do like 2 to the 7 to it, it's not that bad, though. It's not that great either. But yeah, I mean, I think you can do a little bit smarter, right? But the question is whether it is worth it. And what I mean by that is just that, what I mean by that is that you could probably do combinatorial stuff, right? And probably just sum it up, really, right? I don't know if that's interesting. Maybe it is. I don't know. But it is just the maths. Is that easy? Choose one. No. Yeah, I don't know. I guess so. I'm trying to think whether you can do like a 2 to the 7 thing if you do 2 to the 7. But then it may repeat, right? So I don't know. But yeah, I mean, I think given it's a little bit cheating in the sense that given yesterday's problem, I'm inclined to just kind of practice doing branch and bound kind of thing or exhaustive search really because I don't know. But yeah, how do I want to write it? It really doesn't matter that much. There are a couple of ways you can think about it. What I mean by that is that you can either construct all the possibilities, right, and then filter out the dupes, or you can try to construct them in order in such a way that you don't have dupes. The first part is obviously easy, but then it may be or easier, that is. But it may, you may run into issues with running time and stuff like that because very naively, yeah, I mean, 7 factorial times 2 to the 7 is not that big, right? What's 2 to the 7 again? Like 128 times 7 factorial is 500. So that's like less than 1,000,000. So I wouldn't really worry about it, but yeah. Yeah, I mean, I don't think there's that bad. So yeah, let's try to do it recursively, I suppose, right? And then maybe I don't know. That's just the frequency table, and then maybe keys is equal to f dot keys. So those are the characters that we care about, right? And then maybe we have an I call it go just because I'm lazy today, and also it's just like what you're gonna call it, recursive, whatever, same thing, right? And then you maybe have like left, which is the number of characters left. And maybe you can even just say like a current, which is the current array, even though I don't know that we need it if we do it in a way, right? So the way to think about that, yeah, we'll see. I don't know that we need current if we are able to construct it in a way that we don't double count, but we'll see, right? Yeah, and maybe we can work, one step at a time, and then optimize it along the way. Let's do it. Actually, yeah, that's right. Let's do it very naively first, and then we'll see. Right. The reason why I kind of put everything in the frequency table and the keys is so that at every index we don't duplicate characters. Right. Meaning that if our first character is an A, it doesn't matter which A, just matters that it is an A. Right. And as a result, then yeah, we count it. But also maybe I don't even need left is equal to 0 because that also counts this, because we also want to count the prefix. So left equals 0, we just return, I suppose. But otherwise, maybe we have a count is equal to 0. We have a non-local count increment, right? Because that ends the prefix, but we still want to keep going. So then now for this character, we would just write for key in keys, right? If f of k is greater than 0, then we decrement. We do left -1. In theory, we should update k, but I'm like half sold on this, so let's see if this works. I think this should work, but maybe I'm wrong, right? I think that really should be it. But maybe not. I don't know. All right, this is very wrong. Why do I think it's 9? Maybe it's duping something. Let's see. Are all my numbers bigger? I think actually this is right. It's just that I counted the empty string, right? So maybe we just, which obviously we shouldn't count. And if you think about the code, it would count it, right? See if this is fast enough. Looks okay, right? So 1784-day streak, very nice, I suppose. But yeah, but that's pretty much it. I think sometimes I do have a tendency of like having doubts, especially nowadays. I feel like when I was younger, I was much better at this, at just like YOLOing. But I definitely wasn't sure that we need to construct a string. But I think with these kind of enumeration problems, the hardest part is to do it in, because you could do it in any number of ways, but some ways will be a little bit tighter. And the way that I did it here is tight. And the way to phrase it is that for every character, for every index, we want to have a new character, right? So the only way that you get duplicates is if for a given index, you don't dedupe on the index, because let's say you have 2 A's. If your first character is an A and you try it again with a second A, well, that's going to be duped because the rest of the branches don't matter, right? So yeah, because they're going to be the same either way. But yeah, it's always kind of tough to prove correctness if you ask me, just because I'm bad at this. I think you can actually even, like I said, I mean, this one, like I said, doesn't matter that much, but I don't know how to. I want to say you can probably solve this combinatorically, but the way to solve it combinatorically is still very tough, right? Because the idea behind that would be that, for example, if you have, let's take an example, like this string, right? Then now you could say, okay, well, how many one character strings are there, right? Well, that's just 6 choose 1, right? 6 choose 1 divided by something, right? Because this is all the cases, but we have to get rid of these, right? How do I do that actually? Well, like this probably is very trivial to people or some people at home anyway, but I am just really bad at combinatorics, especially today anyway. You choose 1, right? So is 6 choose 1 over? No, I mean there's no need to do that. But this definitely dupes, right? So why am I wrong? I mean, the thing would be like to say is 3 choose 1, but is that how you would do it? That doesn't seem formalic. maybe the one case doesn't make sense. I don't know. Maybe I'm just bad at it. But if you do like something like 2, then you do 6 choose 2, which counts a lot of dupes. And then you have to do some... the thing is that maybe this is the same as this one, honestly. It's just that this one, I'm just struggling. Is that it depends on which 2 you choose. You get to... and it's not... oh, maybe I'm just wrong, actually. This is really wrong. Because because there's no choice in that there is a permutation, right? Or in the sense that like choice is never going to be the answer. I mean, for one, it might be because by coincidence and somehow, but it's never going to be the answer because the order matters, right? So then, how would I solve this, right? I mean, I guess it is kind of structurally very similar to here, right? Is that the first choice we have 3. It's like a factorial thing, and I guess that is kind of like how this goes, right? We have 3 choices up here, and then depends on which one, then... and I guess it literally is this. But can I do it in a way that is much faster? Maybe not. I mean... maybe not, but... you can optimize this with some caching, I suppose. Like you can memorize this for sure with respect to the tiles left, right? With a bit mask or something. The bit mask is a little bit tricky, but you can do it because there are at most 7 unique characters, right? You could do this funky thing with bit mask, but it's just like way annoying. But you can do it. And what I mean by that is that you can actually, yeah, I mean, I'm just going to do it. I don't think this is faster, but I just want to show you that how, like, if you really wanted to cache it, how would you cache it, right? Yeah, I think that's fine, right? So here, then, of course, well, let's rewrite this without caching first because we used a global thing. Then we would do is equal to 1 because of the prefix, and then you would rewrite this as count, right? I don't know why I wrote it. I guess I wrote it that way because I thought I may need to enumerate, right? So you have something like this, and then you want to return this, or maybe this -1 is probably more precise, but the same way, right? So this is the first step before we cache. Oh, I forget. If this is equal to 0, then return count. It doesn't really matter because this would also return 0 anyway, but like you probably don't need this, even though it's slightly slower because it goes through the keys afterwards, right? So this is the same thing as we wrote, right? I don't remember if this speeds faster or not. It doesn't really matter. But then now the thing is that you can actually cache this thing, right? So how you would do that is maybe you have a to function and a from function just to kind of illustrate this. It's annoying to write. I know how to write it, but it's a little bit annoying. But yeah, but here maybe you would have like a okay, there are a lot of ways you can write this, and the way that I'm doing now may or may not be standard. I don't know. I tend to, I wouldn't say invent, but I come up with it. I mean, it may be out there, but I'm coming up with it now, right? And the way that you would turn this into a bitmap so that you can memorize is something like maybe there are a couple of ways you can do it, but the way that I'm maybe thinking about is like a prefix sum kind of thing, right? So maybe you have a prefix is equal to 0. This just gives you the offset, and then for k in keys, prefix dot append, what's it called? I mean, I'm doing really okay. Let's actually keep it even more simpler, right? Which is that yeah, maybe we'll go to key, right? I mean, it's fine, right? Like it's not that big of a deal, right? So we want to put in a to key f, and then maybe it's just something silly like how would I do it, right? Just like a comma limited thing, right? For example, you could do actually even dumber, right? Like you could just recreate the string, So maybe for k in keys, right? Yeah, so like maybe s is equal to and then I know that I'm like all over the place for this part. My apologies, because I am trying to figure out what is the easiest way to represent this as I'm thinking along, and I keep on thinking about easier things to kind of think about, right? So for k, then we do f of k times k, right? And then we return so then this will give us the string, and then now from key is just actually return collections.counter f, right? Oh, this is technically a string, so so then now we convert it to key, right? So then now we have some string, so then from key of s we have f, and then yeah, and then the rest kind of flows, right? Oh, did I forget a comma? I did forget a comma. So again, even for now, we have not memorized, right? But okay. And this thing is too big. It's too big for me to see. Okay, yeah, so to key of f, right? This is going to be slower because we do a lot of overhead, and in fact, we run into recursion stuff. Wait, why? From key. To key. F is a counter. Why is this giving me recursion error? Huh. Actually, I do not know why. The only way that this happens is if something is weird on a conversion and it's not. Oh, this is F and it should be S. That's why. Okay, so it was doing some like weird thing. Okay. So actually, just a silly typo. But yeah, this is probably gonna be slower because we do a lot of upkeep and stuff like this, right? Like converting it back and forth. But then now, what that does is that allows you to cache it, actually. Right. And then now, it still may be slower because just the way it is, but actually, it turned out that this is faster. But, these are the ways that you can think about to kind of memorize this problem, memorize the solution. So yeah, and then now that this is memorized, then you can think about how many what is the complexity, right? Well, now this is going to be 2 to the n. It's basically a bit mask, but it's a little bit better than a bit mask in the sense that a lot of this states are not possible, right? Because due to, like, if you have 3 A's, it's not 2 to the 3 anymore, it's just 0, 1, 2, 3, which is 4, right? So it's kind of like that kind of thing. So that's a little bit better. But you can say it's 2 to the n in the worst case because you have 7 unique characters. It's gonna be 7. This is 7, so this is 7 times 2 to the 7 times 7. So then now this becomes n squared times 2 to the n bit mask, right? I mean, like I said, I didn't do it with bin mask, but that is the same analysis, and that's just like a fun way to do it. So then now instead of n factorial times 2 to the n, roughly speaking, yeah, it's going to be much faster. N squared times 2 to the n, right? Which is better than, and n squared obviously is better than n factorial for modest size of n. But yeah. That's all I have for this one. Let me know what you think. Thanks for watching. Hope you learned something new today because I did it a little bit funky. So yeah, stay good, stay healthy to mental health. Have a great week, everybody. I'll see y'all later and take care. Bye-bye.